what I do in my day-to-day work. This is PowerShell, and I write rootkits to modify the core windows and any single application. And this is just a demonstration of what a rootkit looks like, that it's simply changing an executable in some arbitrary way. I put out a number of tools that allow you to edit applications on disk and in memory. And these allow you to quickly take control of applications or modify what you need inside of it. So this is a hacker talk. This is more offensive. It's not exactly what I might do on a day-to-day in an attack scenario, but these are the basics of being able to reach into an application and exert your will over the application, superseding what the developer developed. So, welcome to Hacking.NET Applications, the Black Arts. This is a rundown of my research and experiences in hacking applications. I'm going to take this in a little bit different direction. So for you on the internet, if you've seen this before, this is going to cover some new research and be a little different than speech in this area. Also, a quick shout out to DenHack. I'll be doing a free training on Monday at 8 o'clock at their new location. So DenHack has moved to this new address, and you can look it up on the internet, Monday, 8 o'clock, free training. So why? What is .NET? It's not Microsoft, it's cross-platform. It's the next step forward from the predecessor languages, and it incorporates a lot of the same syntax and capabilities. It's future compatible, and it's platform independent. This is what .NET is to me. It's not made by Microsoft, it's an open standard like HTML. And it's used by different people for different purposes. It's used by attackers and defenders. This techniques that I'm going to show you is not specifically offensive nor defensive. This is just the ability to impact your application or fundamentally change your world in a way. So if you need your application to behave differently because you're different, maybe you're deaf or blind, or you want to log in without authenticating, you can do so. And so this gives anyone the ability to change their application in a fundamental way. And that's what I'm bringing you. What is an application? How do you access the internals of it? How do you take control of the object model inside of it? How do you access the security mechanisms inside of it? And how do you gain that power that that application controls? That's what I want to show you is easy. In every single language, in every single platform, what I'm going to show you today is no different than what you might do 20 years ago with a C or assembly code program. This is just the way programs are. They're fundamentally attackable. They're on your system, and you control the bytecode. There's nothing preventing anything else. And this is how a lot of people have done reverse engineering and attacking. IDA doesn't necessarily work in .NET, and I'll cover why. Because when you're talking about IDA, you're like, okay, it's a good system. It's a good, clean development infrastructure. It does what it does well. And that's true. In the old days, when you're talking about small applications that were 15K, yeah, looking at single lines of machine code totally worked. And your programs were relatively small and simple, and you were able to move around on a single thread. And that was the old days. That was back in the 90s. Yeah, that totally worked. And it still works against a lot of malware. A lot of malware is very simplistic. But now, we're looking at killing yourself when you're going up against .NET applications. 30, 40 threads. You're talking about games that are megabytes, gigabytes, even terabytes on the servers, and you're going to go through that with IDA. You're not going to look at machine codes. You're talking about object models that are thousands and thousands of instances, and you're going to cruise over that with IDA. And I've done that, and it's painful. And when you're talking about 50 threads, and you're trying to step through that in IDA, it's just not possible. And that's where a lot of my research started, that I wanted to attack applications and bend them and modify them, and it was just completely infeasible. And that's where I delve into the core of .NET. I go beyond the whole Microsoft and Internet and Mono implementations of .NET down to the bytecode, down to the IL is the assembly code of .NET, just like Java bytecode is down there, .NET bytecode is the same. And how do you attack at that level? And that's where I started developing a lot of my tools for attacking at that level. When you're going up an application, 15 lines of C#, that's easy to read over. It turns into 34 lines of IL and 77 lines of assembly code. And it's for just a handful of lines. And that's how much code you have to read in order to impact the application. Here's the 15 lines. You have an application, you compile it, you decompile it, it becomes 15. So it was 13 originally, now it's 15. This is where I work, in IL typically. It turns into 34 lines of IL code. And then in assembly code, it turns into 77 lines. And this is why when you're using IDA, this is what you're going up against. 77 lines of assembly code to do those 13 lines of input code. And that's where that disparaging power comes in, because like it could take half an hour to read over what the machine code does, as opposed to dealing with it in IL at the language level I live at. I'm going to walk you through some of my tools. How do you attack on disk? And so Grey Wolf is a tool that I wrote that allows you to fundamentally modify an application. Going to run you through that. And the basics of attacking with assembly code. So let's open up Grey Wolf attack programs. Go. So you guys are familiar with reverse engineering tools or decompiler tools. This is Grey Wolf. And this is dragging Grey Wolf into itself. And now you're able to, the font's a little off for you, but So these are the namespaces of Grey Wolf. And you're able to cruise the pure namespaces, and I'm gonna, let's see, there we go. Yeah. So this is Grey Wolf itself. I've dragged its own executable inside, and you can now navigate to functions and cruise down and look at the functions. And so this is the source code of an executable. All executables, by nature, give you their source code. When they give you the byte code, source code converts one-to-one into byte code. Theoretically, byte code, for the most part, reverts back to source code one-to-one. It's not quite, but it is. And so you're able to look at something like this if statement here. So this if in C#, I typically work in IL because I go up against protected applications, and this is what I work in. And so when you look at, I'm going to try and change that back again. Okay, there we go. So this is machine code, the byte code of .NET. You have LDST load string, and it loads this here. It takes an ldc.i4.0, that's a 0. That's the definition of a 0. Equals, stack, LDC, load these variables, and then a branch true. And so this is really all you need to understand, that a branch is an if. That's easy. And now you can look through the code and see, okay, here's a branch, here's some no-ops, some pops, some calls, but a branch. And so this branch correlates to the to this if. So we'll take this branch on true. Down here, I have the definition for the byte code. So a branch on true, and we'll turn it to a branch on false. And it's a .s, which is a .short, but nah. So this changes that if statement to be if not key, and then flag. And that is all that it really is. It's the same thing in assembly code. You're looking for that branch statement. It's exactly the same, just on a higher level. So instead of looking at the machine code, you're looking at the IL. And that's what this tool does. You click save down here, and it saves out. And that's the entire cycle. It resigns it, it packages it all together. It doesn't go through source code and recompilation. That's where a lot of the breakdown typically happens in reverse engineering attacks, is you take it through source code, this skips that. So that's looking at assembly, the byte level. I'm going to go a level deeper and start talking about, this is where it gets a little different from what I normally talk about. I'm bringing out some stuff that I've been holding back for a while, just because it's hit the open market and it needs to be out here at OWASP as well. So This is an application. I'm going to walk you through it real quick, and then I can show you what it does. So I have the application load its own domain. So this is every single DLL loaded inside of this application. Real easy. That's a couple of lines of code. I select a domain, and then a DLL, and then I load every single function or class inside of that. And then inside of every single function, or every single class, I load every single function. That's easy. That's a couple of lines of code. You can look up on my website, and this is nice and easy. And so now I reach into the function, and I pull out the machine code. This is going a level below the IL. So we attacked the IL before. We are now attacking the JITted machine code that lives in memory that represents the function. So this is a level deeper than I was just at before. So as I said, attacking that if statement at the IL level is a simple switch. Here, it's a lot more work. It's a lot more ones and zeros to change. So this fires whatever function that I have targeted. It comes in here. This is false. It's a function call. Let's see. I'll step over, and this is false branches this direction. Let's just collapse that. So this is false branches this direction. I just showed you a second ago changing an if statement on disk. We're going to show changing an if statement in memory at the machine code level. And so this is false branches this way, and this message box is shown. Foo test is not hacked. Okay, that's nice and easy. And foo test is not hacked. Okay, so we have our machine code loaded over here. And I'll walk you through how this works on the back end in a second. I have this code down here that does I'm missing, it moved over. Okay, so the smaller screen is making it. So this is a IL code that I've gone through, and this returns a true instead of a false. And this is its memory location, and there, let's see, oh, it's down below. It's right here at the bottom. And this button takes that and will push it up inside of the memory space of the function we have targeted. So I come down here. I don't have my step throughs. Okay, I'll hit. Okay. This is pure raw research. This is just coming out today, and I haven't codified it in a tool, but hopefully in the next 3 to 6 months, this will be a attack platform tool that will be at your disposal. So we're going to step on through, and okay. So just real quick, I want to cover how this is going to inject the information over. I go after the method information, or method info, and I convert the method out into an object. And once I have it objectized, I go through and identify the signature and start objectizing the signature itself. And that should have branched this way. So I'm going to force it over there. Okay, so I objectize the signature and return that. And I basically start in memory understanding the function. So I create a delegate, and this may or may not work stepping through it. I create a delegate out of the signature that I created before, and I'm rolling a delegate raw by myself at this point. Yep, that was unhappy. Cool. I forced it the other way on that branch point. So let's close that out. Debug stop. Okay. I'll rewalk that. Or maybe, I understand what happened. Okay. Done. Come over here. So this is a little bleeding edge, so bear with me. Open project, recent project solutions. That looks like you. Okay. So same thing again. Load up, go through the loaded DLLs, pick my own target self. This would be in lieu of injecting into someone else at runtime. Go into the function, getting the IL, we'll fire the function real quick so it's JITted and it happens. It goes through is false, it branches out, it's not hacked. We take our payload of return true, we load it down here. So you can see this one currently is E8, is the beginning of this function. We're targeting the is false function, E9, yep. We'll blot over it. Skip that, return true is blotted over. Now when I cycle off and refresh this, is false, is now instead of E9, 60. And I've replaced the machine code in IL, in memory, for this function. So when we come back here and fire test foo, we will walk through test foo. And that should theoretically go. Okay. So we're firing test foo. We come in here, is false. Now I'm going to do a step into, and you can't step into machine code. And so it will simply go over. And now we flipped is false to be hacked. So we put a function that returns false. I'll go to definition real quick on this. Peak definition. It's unhappy. Is false. Is false has hard-coded false. So an if statement here, someone looking at this code, doing a forensics report, what happened here? This function that absolutely under every condition always returns false is false. Every single time undoubtedly has now become compromised because we've overwritten it and we've flipped this from is false, which should be down here, to here, and we continue. And so that is reaching in runtime, and now let me walk you through the actual procedure again for overriding memory. So you could technically, before this is a tool, you could come out and do this on your own project right away. So let me walk you through that real quick. Okay, so the basics. We come in here, we get a method info to delegate. So I'm going to take the method info target, so a function target, I'm going to convert it over to a delegate. I'm going to lock onto its signature, understand its signature, and then objectize that. So I can take the old signature and put it over the new one. Signatures aren't terribly important, but it's good. I look at whether or not the target is static, because whether or not you're dealing with static or instances, they get laid out in memory at the machine code level differently. So I'll come in here, I'll create a delegate. So the system.delegate, the pure .NET framework, create a delegate. I have a signature target. I am static, so I don't have an instance variable. And I have what I'm targeting in. So that creates a delegate. That creates a pure raw system.delegate. And that's just the standard .NET framework delegate class. Nothing clever there. But I instantiate a delegate. And that's the beginning. That's where you start with crafting a new function, because you have to have some execution space to run this. Okay, so this is where it gets a little interesting. We have our delegate that we just created. We get a reference to the method pointer of the delegate. Inside of a delegate is a private variable called im_pointer, which is a raw memory. So in .NET, you can raw access a private. You can do this with, here's your type. I want type of system.delegate. I want to get a field. The field is _method PTR, and this is a non-public, so private, and it is an instance variable. And this allows me to access a private. This is how you do it. And so you gain access to this im_private, you get the value, and so I'm getting the value, which is an int pointer, so 32 or 64-bit pointer. And now I have a pointer, and now I'm gonna do, there's a few ways of doing this. I like the Marshall copy for now, but hopefully my tools will have better ways to do it. But there is a system.runtime.interop_service.marshall.copy. So now I have a raw 32 64-bit pointer to the delegate that I created. I'm gonna Marshall copy data raw into it, and that is the sexy for putting machine code into .NET and objectizing and making a pure .NET function out of machine code. I take my shell in here, which is my byte array, that machine code that I had before that I put in that's return true, offsets, the actual pointer, the int64 pointer, and then the length of my shell code. So that's a Marshall copy. Like everyone's probably done that in C++. So now we have the write function. We'll step into that real quick. And so this is just a nice, one of my guys wrote this, and it's just a nice, clean, dirty, go through the length, take the pointer, take the offset, write it in 1 byte at a time. And we were doing that just for development purposes. So with system.runtime.interop.marshall.write_byte. So we're writing in the machine code 1 byte at a time. And in the final release, it'll be much better than this. And let's just breakpoint out of it. Okay, so that's it. I took the machine code, I wrote it in 1 byte at a time to a method. So I had a delegate, I took the delegate, ripped out its function pointer, took its function pointer, took system.interop.runtime.marshall.copy and wrote in 1 bit at a time, and that's how I was able to change the bytecode. And that's it. That's the essential information for how to replicate it. And let's just go in here real quick and here. Okay, we'll do one more cute thing. So why is this impacting to the security world, right? Like now you have this one extra little cute thing that you can do that totally gets you out of the norm. So we'll come in here, go back down to the same thing, go to the test function. We'll do the false function again. And instead of doing return true, we'll use the Metasploit calc payload. And we'll drop the Metasploit calc payload in there. So now we can drop that code in. Okay. And so now this return true that was this, or return false, is now this, the Metasploit calc payload. So now you can mix high level and low level, objectize a Metasploit assembly code payload into a .NET function, and you can do all of the nice evasion in .NET. And now we can run this test foo, and now we come into test foo, and oh, it was debugging, so it was, that should work. We'll try it one more time. Test, I will just put it in foo test, calc, load the calc up, load calc up, fire the test function, and we have calculator pop up. And so now we're able to take low-level Metasploit payloads, get rid of the Metasploit framework itself altogether, and use the delivery payloads raw. So now you can pre-package raw exploitable payloads inside of .NET. You can do crypto, CNCs, communication, sockets, SSL, all of these things up in .NET, and you can mix it with low-level payloads. And that's why it's critical to the security community. Because now, after I release this, you're going to start seeing hybrids. You're going to start seeing .NET assembly code hybrids. AV is not able to go up against .NET. Like, it is cake. You don't even have to try to avoid AV in .NET. .NET will recompile its signature in memory if you have low memory. It'll recompile its signature based on how many processors you have. Its signature is constantly changing. and AV is going to get smashed with this. You can pull out your assembly code and do it one line at a time from .NET, putting in one line of execution at a time. You can do all of these nice wrapping shells in .NET, and AV is going to have a time with this. And that's why it's important, because you're going to see old shellcode exploits coming back with a vengeance when .NET can just fire them. And so now you have cute little .NET functions, and you have little .NET programmers that are able to get that old power and package it up. And that's part of the tool that I'm coming out with, is a nice framework that integrates the ability for developers to use Metasploit payloads. And so in a few months, you'll have that to look forward to. Well, what do you think? Yes.
Is the DLL you were choosing, are you doing this through injection DLLs?
That one was a demonstration against itself. I'll cover memory injection in just another minute. I have a nice tool set for injecting into other processes and controlling and bending them from the outside. But I also I've written a memory injection for .NET as well. But that was a raw proof of concept. Like, other people now have this out in the world, so the community needs to have this. So it's getting out there now instead of later. Normally this would have been a tool and it would have been very clean and professional. Any other comments, like feedback? Like, this is the closest I ever get to people like reviewing me.
So in terms of get access to the machine to get to code to run something?
This is, yes, that would be a post-exploitation. So you are able to drop on a machine, get code execution, and now this is your payload, and the rest of what is in there of the rootkitting. If you look at some of my other talks, I show how you can do advanced rootkitting in .NET and that kind of thing. But yes, this is all post-exploitation. I don't put out any exploits. I don't put out any O-days. Like, this is all just tools. There's no lethality to this at all. Yeah. And that's where we were in the old days. We're now going to this new paradigm. We're talking about people with real power that want to attack in fundamental ways. And now that you can use assembly code in high-level languages, that we're quickly growing, we're quickly changing. And these same assembly code attacks that I'm showing you are also being used in good tools. They're being used in good people are using it as well. And these are not just attack tools. This is actually moving the development community forward. This is being codified in real on-the-shelf tools. And so the game's changing a little bit. I showed you on disk. I'll show you some attacking in memory. I have Gray Dragon, and it essentially allows you to attack at runtime, injecting into memory, into a process, into a function. And this is what happens. This is why injecting a memory is a little different. When you have the Microsoft stuff, you have security, signed DLLs, and this goes through the security system. And essentially all Microsoft has is at the load time, when it comes in and loads into memory. Once it becomes a process, all of the security is gone. And most all of the countermeasures are gone. There's a few that don't, but basically everything is free once you're running process. You can put the payload in there and you're good to go. You're post all of the security. Security doesn't keep checking the entire time. And if it does, it's usually a problem. So, like Best Buy, they had a .NET app. They put it out. And that's where it's like, they have passwords. They have all of this free software. They have all of this capability. And we can go in and attack them. And that's where I don't attack paid applications. I attack demo applications, and I keep it friendly. And that's where I'm trying to set this in context, that I'm doing this to bring this back to the community. I want to show that you can have access to code. You can decompile your applications. You can't put your SA password inside of your application and protect it. You can't. I can infect it. I can take advantage of it. I can exploit it. This is why you need to defend your thick clients, because an exploitable thick client can be deadly to you. And I can remold it easily with just a little bit of ability. And so I'll walk you through doing a little bit of memory injection. Just, has anyone in here, how many of you seen .NET memory injection? Cool, okay, this will be new. Come in here, and this is Gray Dragon, .NET memory injection tool. And we'll select out a, let's see. This is what I wrote to do AWS signing. So I will, more. So the punchline is there is nothing stopping you from injecting into another application. I take this, I drag it over here, I have a target to its PID, I identify its 64, 32-bit, I handle all of the payloads for using 32-bit or 64-bit payloads, and I handle all that behind the scenes, and I load a shim. And this shim allows me to load any arbitrary executable I want into that process. And so the entire injection has finished. I put in one single DLL, and it allows me to load in others. And so now I'm able to take other executables, .NET executables, and load them in. And so this now runs any number of .NET executables that I want. And so these are all loading inside of the same memory space. And I started writing self-aware payloads that would reflect upon the memory space they're in and basically start taking advantage of it. So we can load this, and now every single one of the forms inside of this process has buttons, and the buttons allow you to go through and edit your local memory space. And so as a developer, you're able to say, okay, I want to change all these, right? I want to, I don't know, drag something around. Like, this is simple code for a developer, and this is inside of the memory space. This is exactly the same as the developer's ability. So now what I'm going to do is I'm going to take something like this and serialize it. I'm serializing the events connected to this. And these are just controls. These are data structures, and I'm serializing them. I can come over here to this one, and I can deserialize them. And I maintain all of the events between the different ones. So whereas, let's take a shutdown timer. Yeah, we'll take a shutdown timer and load it in here. So now here's a shutdown timer, okay? Let's see, looking for the payload loader. That one? Nope. The screen real estate is a little light. Ooh. Does that work? Ah, there it is. Okay. So I've told the payload to run again and add these buttons. So now I can take something like this S3 signing application. I can rip this stop button off, serializing its functions. These are all in the exact same memory space. So I have function A over here in the shutdown timer, and I'm going to put it over here. And so now in an arbitrary other application, I have the stop timer. And I can click start, the start starts, and the stop stops it. And so I can now interweave applications functions between application A and B. And that's memory injection, and you're walking the object stack and all of that. And so this might sound a little bit challenging, I suppose. Like, you might look at it and be like, well, how do you actually make a payload for that, right? It's actually pretty easy all in all. You come into Visual Studios, we'll start a new project up, we'll go into references, we'll add a reference, and we will go over to here, attack programs, shutdown timer. And so I can reference another executable. And what does it take to build an attack weaponized payload? I've brought in the shutdown timer, and now I can reference its functions. And so at this point, I would write a custom attack against this shutdown timer. And then I would inject it in, and once it's in, it runs and it goes, and it's built to attack that. And this is where we kind of come full circle. Because back here in Grey Wolf giving us the ability to modify the target. As I said before, there's ways of getting around public and privates. And so if I modify the shutdown timer here, it's modified in Visual Studios. So I can come in here, I can take this constructor. Let's look at the class view. We have, let's see, button hibernate. Yeah, okay, so this is private. So this function right here is private. We come over here to access, we'll change it from private to public. So private off, public on, and so now we have a public function. So now in Visual Studios, you don't have to do any of that, oh, I'm dancing around to private. Visual Studios will let you just access a public. And once you inject, it doesn't care whether something's public or private. That's only in Visual Studios. Public and private is just Visual Studios. At runtime, there is nothing that is impacted by public and private. So we click Save, and we can go in and find that function we want to hit. In Grey Wolf, we can look at the source code. We can do all that reconnaissance. We can make it nice and easy to get there with publics, public, public. And I also included in here publicer that just, you highlight something and you click this button and it makes everything under it public. So now you can import it in Visual Studios and everything is accessible to you. You import that into Visual Studios, you build the payload, you inject the payload in memory into the process, and that is making a round trip. And it's relatively simple. Like you could watch this speech and piece it back together. And that's what these tools allow. And that's why suddenly when you're able to include assembly code, Metasploit, prepackage, all of those old attacks from before, gaining administration privileges and put that into a function, that now you start having these lethal attacks that are able to be put into this lifecycle, and that's why I've been holding it back for years. So does it look, it looks feasible for like a college student, right? Like this doesn't look like someone that needs 6 years of specialized training in reverse engineering. Someone could pick this up in a week. And so that's kind of where I come in for building defenses against this and trying to keep the community ahead of it so you don't get surprised by it. And then this is all running in the same process. This is the host of the process. I've handled threading and all that injection, and when you close it, it closes out cleanly. And I've handled all of that instability in .NET, and I've made a nice little cozy place for you to practice. And so this, as a pen tester, also opens up the doors. When you come up against a client, I've seen so many clients that do obfuscation and they do protection and they've stored the SA passwords in there. And now when you come up against that application, you can use Grey Wolf. I'll just show you real quick because I've had a lot of pen testers get hung up on it. I've made my tools intentionally hard to use without training. So in Grey Wolf, this import button up here, when you import a file through this, it does deobfuscation. And that's the importation of deobfuscation. And that's built into Grey Wolf. So if you come up against a pen test with obfuscation, Grey Wolf does deobfuscation and all of the deprotection. So, cool. Let's run that deobfuscation real quick. I covered it yesterday in my defensive talk, but it's worth saying twice if it's new to you. So we will take a desktop binary. This is my biometric software that I attacked yesterday in my defensive talk, and it is obfuscated. So obfuscation, this is the deobfuscated one. Okay, never mind. Well, you can look at other talks, and I cover deobfuscation and how to go about breaking it, subverting it, and why you don't need to subvert it. How, as a malicious attacker, obfuscation is a hiding mechanism. And if your target is obfuscated and they're using secure development practices, it can actually be a vulnerability that you can hide in, because obfuscation, by default, makes it hard to do a review, a security review, response analysis. And that's where these attacks come back in. And you're able to leverage new weapons in different ways to accomplish lethal goals. So that's looking at attacking shells and exploiting. What is the security that we're going up against? Why can anyone go through any door? And it's pretty much like the fireman story. What building can't a fire crew get into? There isn't a building that a fire crew, if someone is trapped in, can't get into. And that's a fundamental truth of reality. And now you're looking at people that are able to come to your program and attack it fundamentally and start dropping payloads. And part of this is because there's a Visual Studio's exploit that'll run you through real quick, and it's not because we're not secure. It's because computers are so vast, and you're talking about execution of code. And computers like to execute code, like that's their goal. They want to execute code for you. So let's do a new project. We'll come in here to a Windows Forms application. And so this is developing from scratch a exploit against Visual Studios. I will add a user control. So this is adding an arbitrary user control inside of Visual Studios. We'll call it hacker. Okay. Come in here. And let's see, do we have the user control up here yet? Solution, can I do that? We'll do a quick build. So we have hacker user control, and this is all legit and normal. It could be anything. I can come in here to the user control, and I will place a, let's see, common controls. I'm going to put a button on it. I'm going to put whatever on it. Okay, so that's a user control. And this is an exploit that's been known since 2004 to Microsoft, and they refused to fix it. So what we do is we come in here to the user control, open it up, come over here, we'll do a void, tap out. So this is a constructor. So this is hacker, this is a constructor for hacker, and we'll do system.windows.forms.messagebox.show. Hacked. Okay, so when this user control is executed and the constructor is executed for this, we will get the that, close this out. And so close solution. Okay, so I built a solution, and I send it off to one of my friends. And I say, okay, open this up and let me know what you think about it. I found it on the internet. And did the what? Ah. Okay, development's hard. Good catch, thanks. Oh, yep. I program really. So I send this off to my friend. We will close this all out. And this is where you could have this up on CodePlex. Like, what developer doesn't download code and look at it? And this is not running code. This is an exploitation of the framework itself, or of the Visual Studios itself. So we'll open it up. Okay, it's opened up. We'll look through it. Ignore, continue. Did I actually mess something up? That was void hacker. Did I make a public? Or is it unhappy for some reason? Oh. Good call. I really do program. I live in security now, though. Oh, it's already defined in here? Initialize component. Any more? Okay. Well, if I could figure out how to make a constructor, yeah, it says it's already defined somewhere. I don't know. If I could make a constructor, it would run when I rendered the form. But as that I have failed to make a constructor for a class, which you can just assume that I can do, That's exploiting a flaw in Visual Studios, and Microsoft refuses to fix it. And this is because it is a backwards compatibility feature. And so you have arbitrary code execution on developer systems by Microsoft with a known vulnerability that has been in the wild. And so now you have the delivery of on-codeplex Metasploit payload packaged inside of a .NET constructor, inside of a Visual Studios exploit that runs when a developer looks at it. And this is why developers, and I focus on the development community for building security in design and for developers. And so it turns into a lethal little life cycle. Well, that's me, John McCoy, and that's my research in a nutshell. I hope this has opened some doors, and nothing in .NET has allowed me this ability. This is fundamental abilities that's in C++ and every other language that's ever existed. This is fundamental abilities that exist inside of programs. This is not a weakness of .NET. This is just how computers are. And I'm just on the bleeding edge of .NET and making the first headroads into this area. And as a note to the community, I've had that assembly code payload execution for over 3 years, and I've been holding it back. And just this year, it started being released to people, individuals and groups, and that's why I'm bringing it out to the community. And that's where I almost see the proper disclosure of research and lethal tools coming out at OWASP being so important. Because now that you've seen this, you can start, instead of putting it out in a hacker collective or DEF CON, it comes out here and the balance of power changes ever so slightly. So yeah, if you guys have any feedback, if it looks fun and easy, this is my one chance for peer reviewing every year. So thank you so much for OWASP and this. Otherwise, I don't know how I would put this out. I certainly wouldn't go to Microsoft, and I've tried that and it doesn't work. I wouldn't go to companies and Mandiant, that doesn't work. Coming here to the community and giving it to you first, that's what I feel works. So thank you very much. And I got a few extra minutes for Q&A, and I'm happy to talk for as long as you want, and I'm here to help you guys. Yeah? Yep.
What would be an example of a situation where we would need, I mean, you know, here, test this application, we're going to run this, everything. What would be an example of when I would need to do memory injection?
Sure.
I'm running the application, but what would be an example of when that would be useful or relevant?
Yes, totally. If you are a pen tester, I would say the first thing to go and hit is the update mechanism on the program. If you're a paid software and they're doing RC2 symmetric crypto, now you can find that secret key inside of it that allows you just to push. And so now you can go to their enterprise, sit on their network, and just push payloads. A lot of internally developed software has SA or database credentials in it, and developers will typically protect it. This snaps that right out. If you, well, injecting the memory. All right, so say you pop a box, like you're inside of their whatever, and you pop a box. And you could, A, put a rootkit for persistent attack, or you could B, drop it in memory, and when they reset the machine, you're gone. And so now you can tell the client, yeah, we infected this machine with a persistent attack, with a CNC to pivot around, or to keep scanning you, or to keep dropping malware as a demo. You can drop inside of memory. The other things inside of memory that you'll see that would be beneficial is when you do talk to people that are defending their .NET applications, they'll say, well, when you boot up, we'll encrypted stream a DLL down and load it up in memory. And then this blows right past that. That's, in memory, you can, if you're going up against malware, in memory, malware will depack itself, so that's a nice place to hit it. And in memory is usually a lethal attack. As a pen tester, you usually go after reverse engineering on disk. But if you're going after a red team flag and you want to persist on a box, then you could hide in the IIS. You could hide in a little innocuous process, and it's like until they kill that process, you're still there. It's more of an offensive tool in memory. You have another one?
Going along with that,
Yeah.
and this is just my not understanding .NET.
Yeah. Happy.
You know, if there's a system level, I mean, you're on a system and there's a system account
Yeah.
running the .NET application, you come along and you're citrixed into the same box. Can you do these kinds of injections to a process that's running a system when you're not system?
You can, the injections you can't, but now that you have Metasploit payloads at your disposal, you can. And so it gets you over that hurdle the moment you have that ability to run the Metasploit inside of the .NET. So yeah, that's kind of.
So you could get a interpreter under a non-privileged code of yours.
And on top of it, there are some holes that I'm researching, but yeah. But now that you have Metasploit, you like any script kiddie should be able to put them in .NET and crawl up. And any more questions, by the way? Like, yeah. I'll cycle back.
I was just going to ask, so you talked about being able to recover like private keys or something that were hidden or embedded somehow.
Oh yeah.
In .NET, it's not uncommon to encrypt sections of, say, the web.config or the sub.config file.
Yeah.
And you can specify whether you're using a user key or a machine key.
Yeah.
So can you actually get that? I don't know how the machine key, I'm assuming it's from different components on the machine. And
Yeah.
can you get that at the end? I mean, stepping through your injection DLL and then memory to...
Oh yeah. I mean, you can inject in at that last moment and get the user credentials that they typed in. You can. Well, yeah, because it's unencrypted to the process. And if the user logged in with their credentials, and thankfully enough, Microsoft in their SDLC has said if you have any sensitive information stored in a secure string object, which keeps it encrypted in memory, so you have your process and you scrape the entire thing for secure strings and you dump them. And it's very easy to find those now. So you can go in and find user credentials they typed in, security tokens that are live in memory and all that. You can go in and pull that out quite easily. And the difference between, if you can't inject into something, go into Grey Wolf, find one of its DLLs that are somewhere on the stack, and add yourself in as a call. This is, for a pen tester, one of the easier ways to show a client. Instead of showing them injection, what you do is you come in here, you load up an executable. Here's my biometric executable. And so this is a nice way to show a client their software. You come in here, WinTrust class, we'll find a call, and here's a call. We'll repoint this call, and these are all of the DLLs in there. We'll go over to attack programs. We'll take the shutdown timer and drag the shutdown timer in there. And so now I've included my shutdown timer as a referencing. This is an executable referenced as a DLL. And now I can put a call to my function, my lethal function for dropping your creds. And so you do that. Done. And now we have a call out to shutdown timer. And so that could be drop creds to screen in a nice little box. And you embed that in and you put that in a DLL, you load up the program, and now when you hit that one function, it drops the creds. And instead of like, okay, client, I'm gonna inject, I'm gonna do this, it's just their creds are on the screen. And it's a nice little, like this is a great way just to drive home the point that your developers have not protected your creds properly. That I've seen SA passwords in so many internally developed applications because the developers are absolutely sure no one can see it. And so we look behind the doors, right? And that's what a pen tester is. Like, we will get in everywhere. And this is another way to do it. And for the putting a rootkit on a box, now you can hide a rootkit on a server somewhere and say, okay, we penetrated here and we put one rootkit on your network. There's one box somewhere that is rootkitted. Could you find it? Could you find it in a week? And it's like, okay, like you're a security response team and there's one rootkit. Here's the type. Here's the signature to look for. Here's a string in it. Like, here's everything we can give you. Can you find it if you know it is there and it's in these 20 boxes? And it's It's a nice little scary thing because a lot of clients have never seen this kind of attack sequence. And so it's a lot of bang for buck, and it's less than an hour of work. It's pretty cake out the door. And it's stable. I've handled a lot of the stability for you. You had one? Any question? Yeah? How many of you would maybe consider this on a pen test? Like, yeah? Awesome. Cool. The what? .NET is cross-platform. I've confined this specifically to Windows, but it should work out of the box on Linux boxes that have mono included, which is pretty common now, and the .NET's cross-platform, but I've limited the tools, so out of the box, but if I was called into an engagement, it would certainly be there. But yeah. And okay, well, if you guys want to chat it up, I'm happy, and all of these tools are up for free. All of my trainings, all of my techniques are up on Digital Bodyguard, and this is free to the community, so enjoy.